Today we will identify functions. We will also find the domain and range of relations and functions. Relations are basically ordered pairs. They represent a relationship. One example is track meets out of the scoring system. First place gets 5 points, second, third. Third place gets 2, fourth place gets 1. So there's the relation written below. 1, 5, 2, 3, 3, 2, 4, 1. Alright, so there are different ways you can show a relation. We have our table, our graph, and our mapping diagram. So in our table, we have our x, y points. Remember, they were 1, 5, 2, 3, 3, 2, and 4, 1. So we have our table where we list all of our x values, we pair them up with the correct y values, and they're together on the table. There's our graph, and we plotted our points. This is x, this is y, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Notice that these lines are not connected. They're just dots on the graph. First place gets 5 points. There's not going to be any 1.5 place. There's not going to be any 1.1 place or 3.9 place. There's only first place, second place, third place, fourth place. And then you could say that fifth gets 0, sixth gets 0, seventh gets 0. And you could continue on like that if you really wanted to. But what we really want to get the snapshot in is the top 4 places. But they're not connected because there will be nothing in between. And then the mapping diagram, you have your x values on one side and your y values on the other, or your input, and then output would be here. So first place gets you 5 points, second place third, third place 2, fourth place 1. And that is what these would look like in a table, graph, and mapping diagram. So domain is going to be the x values of a relationship, and range will be the y values of a relation. Alright, so we're looking for the domain and range of all of these relations. So remember, the domain is the x values, it's your input. So for this one, your domain is just going to be 1, 2, 3. Those are the x values you're given. Range is going to be your y values, 3, 4, and 5. I always put them in numerical order. So it's just that easy. What about this one? Domain. For this one, the domain is 1, 2, 3, 4. Those are the x values I see. For the range, I only have 2 values, 2 and 5. Now it's going to be a little bit different when you're looking at a graph. Your domain and range for your graph are going to be a little bit different. And let's go over what that looks like. So your domain is your x values. And your range is your y values. So we have 1, 2, 3, 4 here. 1, 2, 3, 4, and 1, 2, 3. So your domain, it starts at 1 and it ends at 4, right? But x can be anything in between. X can be 1.1, it can be 3.9. It could be 1, it could be 4. So x is going to be somewhere between 1 and 4. So 1 is less than or equal to x is less than or equal to 4. X is somewhere in between 1 and 4. The same way as y is somewhere in between 1 and 3. Y can be 1. It can be 2.9. It could be 1.0001. It could be 2.5. So it's anywhere in between these numbers. The reason why we didn't do that before is because we were given specific points. Over here, we're given a graph that's including everything in between. Now a function, that's a specific relation where each input has exactly one output. So each x value is paired with exactly one y value. All right, so let's look at these three relations and find out if they're functions. So the first one, we have an ordered pair 1, 5, 2, 6, 1, 7, 2, 8. Is this a function? Well, we need to know that each x value is paired with exactly one y value. 1 is paired with 5 and with 7. So we know right away this is not a function. But we can also look 2 is paired with 6 and 8. This is not a function. What about this one? X has 1, 2, 3, and 4 paired with y values 5, 4, 5, 4. So since x is paired, each x is only paired with one y value, this is a function. And then we have this mapping diagram, -5, -4, -3, all paired with 1. So each x value is paired with exactly one y value. Now you see here, the y values are repeating. We have repeating y values, but that's fine. We just can't have the same x value repeating. Let's look at one more on a graph. So when we're looking at a graph and we're trying to decide if something is a function, we want to think about having a straight line. Let's actually draw this. A straight line going through it at any point. Now, if this straight line only hits 1 or 0 points, this is a function. If at any point it hits more than 1 point, it is not a function. So let's actually look at one of each. So this is a function. This is not going to hit the graph at more than 1 point. But if we had a graph, we'll just do it like this, if we turned this parabola on its side, if we turn this u on its side, whoops, we can hit the graph at more than 1 point. So this one here is not a function. Not a function. If you wanted more practice on this material that we went over today, you can go to IXL, Algebra 1, Section Q 1, 2, 4, and 5. I'll see you in Zoom.